Welcome for this lecture. Today we are going to discuss the examples on Fourier transform. Let's start with those. First, find the Fourier transform of x of t is equal to e raised to minus a magnitude of t. Okay, that is model of t. Meaning of this one is t is belongs to both the sides, positive side as well as negative side. Okay, at this section t will be positive and at this section t will be negative. Okay, now we have to find the Fourier transform of this and then we have to draw its spectrum. Okay, where here a is a constant term and it is greater than 1. So to deal with this we have to take x of t is this, and then to find out x of j omega is equal to, that is the Fourier transform formula, x of j omega is equal to integration of minus infinity to plus infinity x of t into e raised to minus j into omega t dt. Okay, now in the place of x of t we have to substitute e raised to minus a magnitude of t. So this magnitude or module of t represents the this limits from where to where this signal is. Now we will take x of j omega equal to, this is the formula of a Fourier transform, and now we will substitute in the place of x of t, that is e raised to minus a into module t, and this is e raised to minus j omega t into dt as it is. Now as we have said, this magnitude of t or a module of t which represents positive as well as a negative side. Therefore when you are taking the signal from negative side, you have two sections, from minus infinity to 0 and 0 to plus infinity. Now we will take from minus infinity to 0, that is integration of minus infinity to 0. Here t value is negative, and at this side you can take from 0 to infinity where t is positive, that we have to substitute here, that is e raised to minus a t where t is negative when from minus infinity to 0 and t is positive when the signal was from 0 to infinity. When we are taking this minus infinity to 0, you can observe we have substituted minus t. Then when you are simplifying, other terms remains the same. Only t value we are substituting as negative when it was from minus infinity to 0, and t value is positive from 0 to infinity. Substitute t equal to minus t and simplify this. It will be minus infinity to 0 and e raised to minus a into minus t. It will be plus a into t into e raised to minus j omega t as it is. And in this case from 0 to infinity t is a positive, therefore e raised to minus a into plus t will be e raised to minus at into e raised to minus j omega t into dt. Simplify this term and keep this. So first term from infinity to 0, e raised to at into e raised to minus j omega t into dt plus 0 to infinity e raised to minus at into e raised to minus j omega t into dt. Now we'll take this, simplify. These two bases are same, so we can take t outside. When we have taken t outside, there will be a minus j omega terms remains, e raised to a minus j omega into t dt. And then here we can simplify, e bases are same, then we can take in this in these two factors minus sign outside as well as t outside. When you have taken minus sign and t outside, inside there will be at plus j omega, sorry, a plus j omega, and then integrate it and substitute the values. Very simple thing for us. Integration of e raised to theta will be e raised to theta divided by coefficient of theta. that is e raised to a minus j omega t as it is divided by coefficient of t, that is a minus j omega. And we have to substitute the limits from minus infinity to 0, and second term when you integrate it will be e raised to minus a plus j omega into t as it is divided by t's coefficient, it is minus a plus j omega. Now we have to substitute the limit from 0 to infinity, and from this first factor you can take 1 divided by a minus j omega and then substitute limits. When you are substituting limits t equal to 0 and t equal to minus infinity, first term upper limit minus lower limit. Upper limit is e raised to t, in the place of t we are substituting 0, so it will be e raised to 0 minus e raised to minus infinity. Okay, t we are substituting minus infinity, so it will be minus infinity. Similarly, here you can take minus sign outside, and then 1 divided by a plus j omega you can take outside. Now you can substitute upper limit and minus lower limit. So upper limit will be e raised to minus infinity minus e raised to minus 0. So e raised to 0 is 1, e raised to infinity is 0. Here also same. Now substitute, when you have substituted these values, get 1 divided by a minus j omega into 1 and minus 1 divided by a plus j omega minus 1 we have. So multiply this, it will be a divided by 1 divided by a minus j omega minus into minus plus 1 divided by a plus j omega. So cross multiply this to take a LCM of this. So we can, what we can do is cross multiply. It will be a plus j omega plus this term, okay, that is a minus j omega divided by both the factors multiplication, a minus j omega into a plus j omega. Here j omega minus j omega get cancelled, it will be 2a divided by a minus b, a plus b, so it is a square minus b square, b is j omega square. Here 2a as it is a square minus j square omega square. What is the value of j square? It is minus 1. Minus into minus plus omega square. That is your x of j omega. 2a divided by a square plus omega square. Now we have to draw the spectrum. To draw that spectrum we have to get its values, like omega value is what? At what value of omega, what is the x of j omega? Okay, in this section we are going to substitute 2a divided by a square plus omega square is there. So in this place omega values we are goes on changing. For first value we can substitute 0, and second value at omega is equal to a we can substitute, okay, and then minus a we can substitute. Then we can calculate the magnitude spectra of this. Okay, now we'll see at omega equal to 0, what is the x of j omega? It is nothing but 2a divided by a square plus omega square is 0. So it is a get cancelled, which is nothing but 2 by a. That value we get. When at omega equal to a, then what's the value of x of j omega here? It will be 2a divided by a square plus omega square is a square. So 2a plus 2a square. 2 get cancelled. It is nothing but 1 divided by a. Okay. Similarly, minus a when you are substituted, it will be 1 by a. In the same way, so at omega equal to 0, it will be 2 by a. Okay, and at a it is 1 by a. So 1 by a is a less than 2 by a. Therefore, it will be lesser the value. And at minus a, its value is 1 by a. Same thing, but it is at this side. And next, if you are substituting infinity, when you are substituting in plus infinity, it will be 2a divided by a square plus infinity square. That is nothing but again infinity square. So again it is a infinity. Anything divided by infinity will be 0. So at plus infinity, it is going to be decreasing, and at infinity you are going to reach 0, and at minus infinity it will be again 0. So again it will be 0. Okay, this is your magnitude spectra, right? So at infinity these values will be 0. And next, that is your magnitude spectra we have drawn. Let's see the second example. Find the Fourier transform of the signum function, that is x of t equal to sgn of t. Draw the magnitude and phase spectra of this. Remember, this is one special signal as of your unit step u of t. R of t is a ramp and sine is a sine omega t. Okay. Similarly, we have a signum signal, which means we can define the signum signal like how we used to define u of t, that is unit step function. Its value will be 1 where t is greater than or equal to 0 and its value is 0 when t is less than 0. Similarly, this signum signal is defined as this value is 1 when t is greater than 0 and its value will be minus 1 when t is less than 0. It means at both the sides, positive side as well as the negative side of your graph, this signal will be present. Okay, so now how it will be? The signal will be, the signum function will be defined as signum sgn of t will be equal to 1 when t is greater than 0 and it will be minus 1 when t is less than 0. When you are showing with respect to a graph, it is from 0, t is 0 and its magnitude is 1. And when t is less than 0, that is this side, your magnitude will be minus 1. Therefore, a signal will be, signum signal will be like this. So now we have to find out Fourier transform for this. What we have to do is, if you are differentiating your u of t, you get delta of t. Okay, for example, u of t, if you are differentiating, as we have seen, it's a relation between each signals. We have said du of t by dt, that is if you differentiate u of t, you get delta of t. But in this case, we have two unit step function. One is u of t, another one is minus u of t, that is minus u of minus t. Okay, then both are unit step. Therefore, if you differentiate signum signal, that is sgn of t, you get 2 delta of t. Okay, then it is very easy for us to calculate. We can take a transfer function by using the differentiation property. Okay, so now if you differentiate this with respect to a t, then we get 2 delta of t. Okay, and now taking a Fourier transform on both the sides using time differentiation property, right? So it is nothing but you can take sgn of t, we have taken it as a x of t signal, then it will be, it is nothing but dx by dt signal, which is equal to 2 delta of t. Okay, we have to apply Fourier transform for this by using time differentiation property. What is the Fourier transform of differentiation function x of t? It will be, we have to apply Fourier transform for this as well as Fourier transform for this. So when you are applying Fourier transform for a differentiation function, it will be equal to j omega into x of j omega. Okay, so now j omega into x of j omega, 2 into Fourier transform of delta will be equal to 1. Fourier transform of a delta of t will be equal to 1. So 2 into 1 we can write here. Okay, therefore x of j omega will be equal to 2 divided by j omega. Okay, this is your Fourier transform of a signum signal. Now we need to draw its magnitude spectra as well as the phase angle spectrum. So now we'll take x of j omega as it was 2 divided by j omega. If you are taking it j up, then it will be minus 2j divided by omega. So to get a magnitude of this signal, it is nothing but 2 divided by omega only, because when you are taking a magnitude, we can consider this only as a real part, that is 2 divided by omega. Okay, and to get a magnitude of it, it will be x of j omega, which is equal to, you can take this one. Okay, you can consider here j is below this part, so it is nothing but minus tan inverse of omega by 0, that is real part divided, imaginary part divided by real part. There is no such real part here. It is directly 2 by omega is your imaginary part only. There is no real part in this. Therefore, you can take minus tan inverse of 2 by omega divided by 0. So then that is nothing but minus tan inverse of infinity. X of j omega will be equal to minus pi by 2, where omega is greater than 0, and it is true where it will be equal to pi by 2 when omega is less than 0. Okay, and as I told you, this is magnitude of this signal is nothing but square root of real part square plus imaginary part square. Since we not have a real part, we can neglect this. Imaginary part is minus 2 by omega. So when you square it, it will be, you can square this, so minus minus plus will be there. 2 by omega, square root of this one will be get cancelled, so it will be 2 by omega. Now we have to draw both the cases. Magnitude spectra, for magnitude it will be 2 by omega, and for angle, see, for angle it will be minus pi by 2 when omega is greater than 0 and plus pi by 2 when omega is less than 0. So now we'll draw magnitude of this 2 by omega. Let's substitute omega equal to 0. What is the value? And at omega equal to 1, 2, 3 and so on up to infinity. So when you are substituting omega equal to 0, 2 by omega, that is 2 by 0 will be, anything divided by 0 will be infinity. And at 1 it will be 2, and at 2 it will be 1. Okay, this omega value goes on changing. Then at 3 it will be 2 by 3. At 4 it will be 1 by 2. Correct? 2 by 4 is nothing but 1 by 2. And so on. If you are substituting omega equal to infinity, anything divided by infinity will be 0. So these values we have to substitute. So this is true for positive side. Okay, similarly we have to substitute for negative side as well. So when omega is, we'll take omega as 0 is okay. I'll substitute minus 1. When we substitute minus 1, it will be 2 by minus 1, value is minus 2. And when you are substituting at minus 2, omega equal to minus 2, it will be 2 divided by minus 2, then it will be minus 1. Similarly, minus 3 if you substitute, you get a minus 2 by 3. Minus 4 if you substitute, it will be minus 1 by 2. Minus infinity you substitute, again it will be a 0. Now what we can do is, first we will substitute positive values. Okay, positive value will be, if you substitute 0, it will be infinity, means from somewhere, right, from infinity it is goes on decreasing. Correct, it goes on decreases. I'll take for a positive values now. For a positive values it goes on decreases. Yes, I can take like this. At infinity it is going to reach 0 value. Similarly, when we substitute negative values, then you get negative values of this same. Therefore that one also, when you substitute like minus 1, minus 2, minus 3 and so on, so this is going to be reduced like this. It is your magnitude spectra. Similarly, we get phase angle, as we have said, it is true, that is it is minus pi by 2 for omega is greater than 0 and pi by 2 for omega less than 0. So for this what we can do is, directly we can write at omega is greater than 0, yes, this part it will be minus pi by 2, then this is the your angle, phase angle, and pi by 2 for omega is less than 0, this is the part where omega is less than 0, that time it will be plus pi by 2, this is your plus pi by 2. Therefore phase spectra will be like this, that we can observe here. This is a magnitude and this is phase. Now we'll move to next example. Find the Fourier transform of the signal x of t equal to t into e raised to minus 2t into u of t. We can do it directly, that by taking a Fourier transform of this, that is x of j omega equal to integration of minus infinity to plus infinity x of t into e raised to minus j omega t into dt. Now we'll substitute x of t as e raised to, that is minus infinity to plus infinity, x of t is t into e raised to minus 2t into u of t into dt. Now this limit has to be decided by this u of t. U of t means from 0 to plus infinity. Therefore it should be integration of 0 to infinity t into e raised to minus 2t into e raised to minus j omega t into dt. So now simplify this term, that is 0 to infinity t e raised to minus 2t into e raised to minus j omega t into dt. Now we'll take this 0 to infinity t as it is, bases are same, e raised to minus sign will take outside and t also will take outside, 2 plus j omega into t into dt. When you are integrating, you can do integration or you can follow the your time shifting property, that is frequency time shifting property. Now we'll go directly and later we can make use of this formula. Okay, directly now we'll go conventional way, that is integrate this. There are two factors u into v. Okay, keep first function as it is, that is t, integrate second function, that is e raised to minus 2 plus j omega t. Okay, minus integration of the second function, that is same thing, e raised to minus 2 plus j omega of t into differentiation of first function. Okay, when we do this, we get, when you do this, so this is the formula, first function as it is, this is u and v, first function as it is, integration of a second function minus integration of second function into differentiate the first function. Let's just differentiate it, means let's do the integration, keep as it is this, and then it will be e raised to minus 2 plus j omega of t divided by coefficient of t, which is minus 2 plus j omega, then minus integration, first integration as it is, second integration will be same, integration of e raised to 2 plus j omega t divided by coefficient of this, it will be 2 plus j omega into differentiation of t with respect to t will be 1. Okay, and then for this term we have to substitute 0 to infinity. Okay, so for this will take minus 1 divided by 2 plus j omega outside, this minus sign will write here, minus 1 divided by 2 plus j omega, here we will keeping t e raised to minus of 2 plus j omega t. Substitute upper limit minus lower limit. Upper limit is infinity. When you are substituting infinity here in the place of t, it will be infinity into e raised to minus infinity. Okay, and then minus lower limit is t place we have to substitute 0 into e raised to 0. E raised to infinity is 0. When you are multiplying 0 with infinity is again a 0. So this term will be 0. Minus 0 into anything will be again a 0. So it is also 0. Now we'll take a second, we'll concentrate on second part now. We have to integrate it one more time. For that there is a minus sign. So this minus sign and this minus sign will be again plus. So take 2 plus j omega outside, that is 1 divided by 2 plus j omega outside, and then integrate this part, that is from 0 to infinity e raised to 2 plus j omega of t. Integrate it, e raised to minus of 2 plus j omega t divided by coefficient of this, that is 2 of 2 plus j omega. Substitute its limit of infinity and 0. So this part will be 0, and then minus sign you take outside, that is this minus sign into plus will be minus. So 1 divided by 2 plus this 2 plus j omega also you can take outside. So 2 plus j omega into 2 plus j omega will be 2 plus j omega square. Substitute the upper limit minus lower limit, that is e raised to t place, we have to substitute first infinity, that will be e raised to minus infinity, and then minus lower limit, that is nothing but 0, e raised to 0. So e raised to infinity is 0, e raised to 0 is 1. When you substitute this term, first term is 0, second term will be minus 1 divided by 2 plus j omega square. Its value is 1 and this value is 0. When you substitute it, minus into minus will be plus 1 divided by 2 plus j omega whole square. Whenever we get Fourier transform of t into e raised to minus 2t, then we can write it is nothing but 1 divided by 2 plus j omega whole square. If it is of minus 3t, then we'll be taking as 3 plus j omega whole square. And then we'll do with the another one, which is find the for the signal x of t shown below, find the Fourier transform. To find the Fourier transform, first they have given a graph, means a signal. Now we have to get in the form of equation, then only we can write. So define this signal. First one will take x of t. X of t is true, that is x of t, which is equal to magnitude 1 when t is between minus 2 to 0. Okay, and this its magnitude x of t is present, one more signal, that is with a magnitude minus 1 when t is between 0 to 2, and other than this signals are 0 otherwise. Okay, first we have to define the signal, that is x of t. Only we have this signal and we have this signal. First signal is from minus 2 to 0 and another signal is 0 to 2. There are two signals. First signal is between minus 2 to 0 and second signal is from 0 to 2. Then when it is from minus 2 to 0, its magnitude is plus 1, and when it is 0 to 2, its magnitude is minus 1. Otherwise this will be 0. So now we can easily write that x of t equal to, that is x of j omega, that is Fourier transform of this given signal, will be equal to integration of minus infinity to plus infinity x of t into e raised to minus j omega t into dt. Now in the place of x of t, we have to substitute two things, that is first signal and a second signal. So x of t will be equal to, first signal is from minus 2 to 0. What is the magnitude of its? 1. And another signal is how much? It is from 0 to 2. It is 0 to 2. What is the magnitude? Its magnitude is minus 1. This into e raised to minus j omega t into dt. Now we have to expand it for both and then do the simplification. This will be x of j omega. X of j omega will be equal to, first one, minus 2 to 0, 1 into e raised to minus j omega t into dt, plus second signal, that is 0 to 2, 1 minus 1 into e raised to minus j omega t into dt. We'll take this, right? This is minus 2 to 0, 1 into e raised to minus j omega t. This minus, another signal is 0 to 2, minus 1 into e raised to minus j omega t. This minus we can take here, then we can take it as a minus sign. Differentiate it. It is nothing but integration of minus 2 to 0, e raised to minus j omega t into dt. So if you integrate it, it will be again e raised to minus j omega t divided by minus j omega. We have to substitute the values from minus 2 to 0. Another one is minus integration of minus j omega t into dt minus j omega t divided by minus j omega. Okay, this minus and this minus, again it will be a plus. Okay, integrate it, substitute the values. Here also integrate it, substitute the limits. Take first factor, that is minus 1 divided by j omega outside, e raised to minus j omega t is there, substitute the values of this, and then minus sign plus 1 divided by j omega into e raised to minus j omega t of 0 to 2. Now we'll take minus sign as it is. So this substitute upper limit e raised to 0, lower limit wherever you have a t. Okay, wherever you have a t, in that place you have to substitute minus 2. Then e raised to minus j omega into minus 2. Okay. Similarly, in this case also, plus j omega, that is plus 1 divided by j omega, e raised to j omega, t value is 2, upper limit, minus lower limit is 0. Its value is 1, its value is also 1. So then expand this terms. Minus 1 divided by j omega plus minus into minus plus, then e raised to j omega j2 omega divided by j omega, then plus second factor plus e raised to minus 2 j omega divided by j omega, and then plus into minus minus 1 into 1 divided by j omega will be 1 divided by minus 1 divided by j omega. So minus 1 divided by j omega minus 1 divided by j omega, it will be minus 2 divided by j omega. So then second factor is these two, that is e raised to j2 omega plus e raised to minus j2 omega divided by j omega. So to this, it is nothing but you can compare it with this, e raised to j theta plus e raised to minus j theta divided by j or 2j. It will be nothing but, it is nothing but cos theta for us. Okay, not j. Cos theta is nothing but e raised to j theta plus e raised to minus j theta divided by 2. This is the formula for us. So just compare with that thing. You can compare this, I can take j omega outside, then compare with only this term, that is e raised to j theta plus e raised to minus j theta. It will be nothing but 2 cos 2 omega. Cos theta will be equal to e raised to j theta plus e raised to minus j theta divided by 2. Here we have e raised to j theta plus e raised to minus j theta equal to what we have to write, 2 into cos theta, where theta is 2 omega here. Substitute same value here, that is nothing but upper part, that is denominator as it is. Numerator is 2 cos 2 omega j omega. So simplify, numerator is the denominator is common, minus 2 plus 2 cos 2 omega, then rewrite it properly, then take a 2 outside, then it will be cos 2 omega minus 1 divided by j omega. This is Fourier transform of the given signum.